Hello viewers, you're welcome back to my channel. This is the first video I'll be making since my first algebra teacher, that is my mom, passed away. She started teaching me algebra at a very tender age of 4. I appreciate her for that. I'm dedicating this video to her. May her soul continue to rest in peace. Love you, mommy. So here we'll be looking at 6.5, which is the inverse of trigonometric functions and their graphs. So we discussed earlier, if you look at my videos, section 2.8, we talked about inverse function. And we said the inverse of a function exists if and only if the function is 1-to-1. So if a function is 1-to-1, then we can talk about the existence of its inverse, right? But for trigonometric functions, they are not 1-to-1. So for example, this is the graph of sine x. Now, if I draw a horizontal line, you can see that it's going to intersect the graph more than one point, right? So it means that naturally sine is not a 1-to-1 function. But we can restrict the domain in such a way that the function can become 1-to-1. If you remember, if you have a function, let's say, let's give you just, this one is the function x squared. This is not 1-to-1, but we can make a restriction to make this function 1-to-1. For example, we can just take this part. It means that this is x squared when x is less than or equals to 0. And you can see this function now is 1-to-1 because if you draw a horizontal line, it will intersect only at one point. So the same thing we're going to do here with trigonometric functions. So this is sine. Now this is the graph of sine, 2 period of sine x, which is from -2 to 2 pi. This is 2 periods, right? Because remember, a period of sine x is just from 0 to 2 pi. So if we restrict the domain now, if this is minus pi, this is going to be minus pi over 2, right? And if this is 0, this is pi. This is also pi over 2. Now, if we restrict the domain from minus pi over 2 to pi over 2, we will have this graph. And you can see that this function is what? Is 1-to-1 because it will satisfy the horizontal line test. So therefore, anytime we talk about sine inverse, it means we have restricted the domain of sine just to be from where? From minus pi over 2 to pi over 2. So you can see now this is 1-to-1, right? Okay. Now, how does the graph look like? The graph of sine inverse of x looks something like this. This is simply, if you have the graph of f, to get the graph of f inverse, you just need to reflect the graph of f across the line y equals to what? X. So if you have like a line here, the line y equals to x. So if you reflect this one, you will have, we will have this graph there. Or we can take points. For example, another way to look at them is to take some points. If you take some point, for example, this is a point on the graph of f, which means that x is what? Is pi over 2 and y is 1, right? Now, this is on the graph of sine x. On the graph of sine inverse of x is going to be what? It's going to be 1 pi over 2. And that is what you can see here. You can see here, this is 1. And the value here, this is a point, pi over 2. So you could take as many points and just take points, about 4 points from the graph of f, which is the graph of sine, Then you interchange the position of x and y, and then you plot the graph. So let's just, you can take another point here, which is very obvious, is the point 0, 0, which is this. Now, on the graph of sine inverse, it will still be 0, 0. And you can take another point here, which is, which point is that? Minus pi over 2 and 1. Oh, no, and minus 1. And then it will become minus 1 and minus pi over 2, as you can see here. All right, so now another thing we can see from the graph of sine inverse is that what? This graph, sine inverse of x, is symmetric with respect to origin, right? So you can see it's symmetric with what? With origin. Now, since it's symmetric with origin, what does that mean? It means that what? Sine inverse of x is what? Is an odd function, right? Is an odd function. And what does that mean? Being an odd function, so it means that if you have sine inverse of minus x, right, is going to be the same as minus sine inverse of what? Of x. So the minus can come out because sine inverse is what? Is an odd function. Okay? So, for example, if we want to find sine inverse of what? Minus 1, we can take minus outside. So you have minus sine inverse of what? Of 1. This is a true statement. Or, now, another thing about sine inverse, we have this, what we call the, so here, let's just define this one. This one follows from where? If you have sine inverse of x equals to y, then it means sine y is equals to x. Now, this also follows from what we've discussed earlier. Let's talk about the domain first, and the what? And the range. So if this is sine inverse of x, now what is the domain? Remember, what is the domain of sine inverse of sine x? The domain of sine x is what? Is minus pi over 2 to pi over 2. So it means that the range of sine x, what is the range of sine x? The range of sine x is still minus 1 and what? And 1, right? Okay, now, what is now the domain of sine inverse of x? The domain of sine inverse of x is going to be the range of sine x, which is going to be minus 1 to 1. Why the range of sine inverse of x is going to be the domain of sine x, which is minus pi over 2 to pi over 2. So take note of this. Remember, if you have a function, then you can get the domain and as well as the range from that of the inverse function. Okay. Now let's dig a little bit deeper. If you remember, in still in section 2.8, we discussed something called the cancellation functions, right? The cancellation property, let me just discuss it here. It means that if you have f inverse of x, we saw these two properties. This is equals to x, right? But this x must come from where? Must come from there. Look at x. Which function is acting on x first? It's f inverse. So it must come from the domain of f inverse, right? So now, what we're going to do is take the function. What is our function? Our function, f of x, let's take f of x to be what? Sine x. And its inverse is what? Is sine inverse of x, right? So if we use this property now, this one, so this means that what? Sine of what? Sine inverse of x is equals to what? X. But this x must be in the domain of f inverse, which is the domain of what? Sine inverse of x. But what is the domain of sine inverse of x? We wrote it here. The domain of sine inverse of x is the closed interval minus 1 to 1. So that is why we have this first property here. See? Now, also, if you look, we also have this same property. If you have f inverse of f of x, you know this is also equals to x. But in this case, the x should come from where? From where? The domain of what? Of f, right? So it means that whenever you have sine inverse, if you compose sine inverse and sine x, right? This is equals to what? X. We're going to use these properties later. So is equals to x. But this x now must come from where? Look at the x. What is acting on x first is the sine. So it must come from the domain of sine. And what is the domain of sine? Is this one. So this x must come from minus pi over 2 to pi over 2. So that is why we have these second cancellation properties. Okay. All right. Now let's talk about cosine as well. So for cosine, it's still similar. Ordinarily, this is cosine, the graph of cosine from minus 2 pi to 2 pi. And as you can see, that cosine is not what? It's not 1-to-1. But if we restrict it to from 0 to pi, which will become this one. So this is our cosine. And you can see that this is 1-to-1, right? This is 1-to-1. And since it's 1-to-1, it means we can find the inverse. So the inverse is this one. This is the inverse graph, which is the same thing I explained earlier. You just reflect this graph across the line y equals to x. It will give us this one here. So this is the graph of cosine inverse. But something to note is that look at this graph. If you look at this graph, it is not symmetric. It is not symmetric to the what? It's not symmetric to the y-axis. And it is not what? Symmetric to what? To the x-axis, right? And what does that mean? It means that what? It means that cosine inverse is neither even nor what? It's neither even nor odd. Okay? Now, what does that imply? What that simply means is that what? If you have cosine inverse of minus cos x, of minus x, is not the same thing as what? Cosine inverse of x. You know, we know cosine is even, right? So because cosine is even, it consumes the minus, right? But in the case of cosine inverse, it's not true. You cannot consume the minus. Also, cosine inverse of minus x is not the same thing as what? You cannot take the minus out. So take note of this. This means that it is not even and it is not what? It is not odd. All right. So the property we will see here, this is also what I explained earlier. This is the cancellation property for cosine. So if you compose cosine and cosine inverse, your answer is going to be what? X. But where would this x come from? It's coming from the domain of cosine inverse. So it means that if you have domain of cosine, what is the domain of cosine? It's going to be 0 to pi. What is the range of cosine x? It's still going to be minus 1 to 1, right? But if you talk about the domain of cosine inverse, the domain of cosine inverse is going to be the what? The range of cosine. So it's minus 1 to 1. And the range of cosine inverse is going to be the domain of cosine, which is 0 to pi. Okay. So here you can see if you have cosine inverse of x, this x must come from the domain of cosine inverse. And what is the domain of cosine inverse? Is minus 1 to 1. In the second case, if you compose cosine inverse and cosine x, this x should come from the domain of cosine. And what is the domain of cosine? Is from 0 to pi. So let's see now. Let's talk about tan. The same way, we know that tan is not 1 to 1. Why is tan not 1 to 1? If you remember, this is the graph of tan. With repetition, if I draw a horizontal line, you see, it's not going to be, it's going to cut more than 1, right? So it means it's not 1 to 1. But if we restrict tan to only, let's just restrict it to only the red one, which is from minus pi over 2 to pi over 2. So if you restrict it to only the red one, it means it's going to be 1 to 1, because if we draw a horizontal line test, it's going to cut only at where? At one point. So that is why we're saying that the domain of tan x is what? Minus pi over 2 to pi over 2. But what to note here is that the pi over 2 here is not closed, it's open, right? Because we know we have vertical asymptotes at minus pi over 2 and at pi over 2. All right. Then if we take this graph, this is the tan inverse, which is just the reflection of this red one across the what? The line y equals to x. So this is the graph of tan inverse, right? Now, one thing we can see from tan inverse is that what? It is symmetry, right? Is it symmetry? Is it symmetry to origin? Yes, it is symmetric to origin, yes. Because this is the origin. So if you look through this, what you see here is just what you see there. So this is symmetric to origin. And what does that mean? Which means that what? Tan inverse is what? Is odd function. And what does that mean? That means that what? If you have tan inverse of minus x, is the same thing as minus tan inverse of what? Of x. So here, let me just, the domain for tan x, what is the domain? The domain is minus pi over 2 to pi over 2. And then the range of tan x is the whole of R. As you can see from the graph, this is the range of tan x. But now, if we talk about the domain of tan inverse of x, is going to be the range, which is minus infinity to infinity, while the range of tan inverse of x is going to be the domain, which is minus pi over 2 to pi over 2, right? So this is it. Now, so this is just the brief descriptions of this inverse function. And something to note here is that what? when we talk about inverse functions, we're not talking about the reciprocal. So sine inverse of x is not the same thing as 1 over sine x. Because 1 over sine x, we know this is what? This is cosec x, cosecant x. And the same applies to tan inverse of x is not the same thing as 1 over tan x. Because 1 over tan x is what? Is cotan x. All right, so this is just a brief explanation how we can find the domain. We can restrict the domain of trigonometric function so that they become one-to-one, right? Now, here, like in the case of sine and cosine, we could have taken other restrictions, right? For example, if you look at this, here we restricted what we use for the cosine, we use 0 to pi. But we could have used also from minus pi to 0, right? Which will still be one-to-one. But but we don't use, we use this, these are the standard ones, standard restrictions, 0 to pi. And also in the case of sine, minus pi over 2 to pi over 2. So in the next video, we'll see how to evaluate inverse trigonometry functions. For example, how do we evaluate sine inverse of 3? Is it possible? Or sine inverse of half? How to get these values. So thank you for watching. So thank you. If you have any question, you can just put it in the comment section.